Hello and welcome to this special webinar on Arizona and New Mexico monsoon recap and winter drought outlook. My name is Joel Lisenby. I'm the Regional Drought Information Coordinator for the Intermountain West and Southern Plains regions at the National Integrated Drought Information System, or NIDIS. It is NIDIS's mission to help the country move from a reactive to a more proactive approach to managing drought risks and impacts, and you can learn more about NIDIS at drought.gov. To begin today's webinar, I would like to acknowledge that the land that each of us is on today is the ancestral land of tribal and indigenous cultures, and pay my respect to their elders and chiefs, both past and present. I welcome all tribal and indigenous peoples who are joining this webinar today. This webinar is truly a collaborative effort and was produced by input, effort, time, talent, and expertise from the organizations that are listed on the screen now. For the sake of time, I will not be reading through them, but I would like to thank everyone who's contributed to the webinar today. You know who you are, and you're appreciated. The format of today's webinar will be a series of presentations followed by a time for questions and discussion on impacts to tribes and other Southwestern communities, which you're invited to participate in if you feel comfortable. With a group this large, we found that questions go much smoother. If you will please type your question into the Q&A box at the bottom of the screen. This is different from the chat box. If you look at the bottom of your Zoom screen, you'll see a Q&A separate from the chat. Go ahead and type your questions in there as they come to your mind, and the panel will address them at the end of their presentations. Before we get started, I'd like to cover a few quick logistics. To begin with, everyone is muted, and this webinar is being recorded. The webinar recording will be available from the Southwest Climate Adaptation Science Center website. To find it, first navigate to swcasc.arizona.edu. Then hover over the word outreach, then select the webinars option, then click on the link that says past webinar recordings, and you'll be there. You'll be able to find and share this webinar after it's finished. I would like to introduce and welcome today's speakers. First, we'll be hearing from Dr. Mike Crimmins. Dr. Crimmins is on the faculty of the Department of Environmental Science at the University of Arizona and is a climate science extension specialist for Arizona Cooperative Extension. In this position, he provides climate science support and resource managers across Arizona. He provides support to resource managers across Arizona by assessing information needs, synthesizing and translating relevant research results, and conducting applied research projects. His extension and research work supports resource management across multiple sectors, including rangelands, forests, wildfire, and water resources, as well as informing policy and decision makers. This work aims to support managers by increasing climate science literacy, as well as developing strategies to adapt to the changing climate. He also serves on as a drought monitoring expert on the Arizona Governor's Drought Task Force and has worked with counties across Arizona to implement drought preparedness and impact monitoring plans. And Mike will be giving us a monsoon review and drought status update for Arizona. Immediately following Mike's talk, we'll be hearing from Dr. Dave DuBois. Dr. DuBois is the state climatologist for New Mexico, and he's the director of the New Mexico Climate Center and associate college professor at New Mexico State University. He provides climate and climate change information and education to policymakers, the agricultural community, industry, educators, students, and the general public. In addition, he also gives numerous talks and holds workshops every year on topics covering climate, drought, air quality, and climate change. Dr. DuBois teaches and trains students at New Mexico State University and maintains an active research program in air quality and climate. He also chairs the New Mexico Drought Monitoring Work Group. Dave is a native of New Mexico, but he grew up on a farm in southern New Jersey. And Dave will be giving us a monsoon review and a drought status update for New Mexico. Immediately following Dave's presentation, we'll be hearing from Mike Halpert. Mike is the deputy director at NOAA's Climate Prediction Center. He is an expert on short-term climate variability. He leads teams of scientists who make sub-seasonal and seasonal predictions and monitor climate forecasts and that influence weather and climate, such as El Nino, the Madden-Julian Oscillation, and other teleconnection patterns like the Arctic Oscillation. Mike is among the world's leading experts on the El Nino Southern Oscillation and its related impacts. and has co-authored many journal articles on climate variability and climate prediction. And Mike will talk to us about the climate factors and outlook leading us into this coming winter. Following Mike's talk today, the Q&A discussion session will be facilitated by Sarah Leroy and Katie Steele. Sarah is the Science Communications Coordinator for the Southwest Climate Adaptation Science Center, and Katie is the coordinator for the USDA Southwest Climate Hub. And with that, I will pass over to Mike Crimmins for our first presentation.
Thanks, Joel. Okay, hopefully, can somebody give me a thumbs up?
Yep, we can see that.
Okay, great. Good morning, everybody. Thanks for the introduction, Joel, very kind. I'm Mike Crimmins again at University of Arizona, and I'll be doing the monsoon review and drought status update for Arizona. And it's going to be weird to talk about a record hot and dry monsoon where it's a very chilly morning across the Southwest, 34 degrees here in Tucson when I woke up this morning. It's a far cry from the 110 days that we saw end on end this summer. So I think everybody's fully aware of where we're at with drought status. We'll talk a little bit more about the current drought monitor map and how we got there. But I think it's interesting to think about this very cold morning after this hot summer with the whiplash that we've been seeing over the last couple of years. And it's actually hard to remember even a year ago and a couple of months where much of the Southwest was actually drought free. We've actually had a couple of decent winters across the Southwest, especially for Arizona in particular. And Dave has a little bit different story, I'm sure, for New Mexico. But in Arizona in particular, we'll talk about last monsoon season, last winter, and this monsoon season. And hopefully it'll set the stage for trying to understand the impacts we might be seeing with the La Nina event evolving right now. But if we look at the June 2nd, 2020 drought map, which was just a couple of months ago, we were largely drought free except for the Four Corners region. So up in Hopi and Navajo, there was some lingering drought conditions, and more broadly across the Four Corner region from not seeing as much winter precipitation. But if you went to central and southern Arizona, we actually did see some average to above average precipitation. So just setting the stage for sort of pre-monsoon, we can really see the evolution of the failure of the monsoon show up in the drought monitor map. So by July 28th of 2020, the drought monitor map starts to pick up, especially across southeast Arizona, where we would have expected to see the precip show up first. We start to move very quickly from drought-free into severe drought conditions just within about 8 weeks. And then by September 1st, largely past the peak of the monsoon season in early August, the die was cast for the monsoon season really much being over at that point and quickly progressing from severe to extreme drought. And then by the end of September, any chance of picking up any tropical storm activity or sort of catch-up events at the end of the month were gone. And we see that the extreme drought and even the rare exceptional drought starts to pop up, and I expect we'll see more of that kind of spread across the Southwest. So just looking at Arizona's drought monitor, the percent coverage across the whole state. And so if these are in the different drought categories, as you see in the maps up there, the last drought that we had of this extent was the 2017-2018 drought, where we ended up having not a bad monsoon, but then quickly a shutdown of any winter precipitation. And this was associated with a La Nina event, I believe a weak to moderate one. And very warm, very dry conditions in the wintertime and very little precipitation actually until later in the spring. And so that was the last time we saw a drought extent of this magnitude across Arizona in particular. And you can see at the very tail end of this graph, a little bit more of that extreme drought and even the exceptional drought picking up. And so this is in the last 20 years, or in the whole extent of the drought monitor map, sort of a rare conditions. And we haven't seen the last couple of years. And even in the longer term drought situation, these are much more expansive categories of these more extreme and exceptional drought categories. Okay, so looking at the full water year. So this will actually bring in last winter, which I think is important for us to understand some of the drought indices we're looking at right now, because we really do have a mixed signal. We've got a mixed signal of in different parts of the Southwest and in Arizona in particular. we've got record hot and dry conditions in the summer, and then pretty mediocre or moderate temperatures, slightly above average and wetter than average conditions last winter. So when you average those together, you get this kind of mixed signal. And the impacts will emerge in different areas in different seasons, depending on missing that precipitation. So this top graph here is looking at the water year, looking at last September through this, through last October through the end of this past September. So at the end of last month, so that 12-month water year period. And across Arizona, again, that four corners where those drought conditions really did hang around, still present. But then the southern part of the state, and even the southwest part of the state, which is typically very dry, ended up seeing above average precipitation. But when we do add in the temperature aspect, which is really important for us to consider at all time scales now, it was warmer on average over this entire time period. And so any of those gains in average to above average precipitation, in this particular drought index, the standardized precipitation evapotranspiration index, those gains are actually lost because of the above average conditions. So even near average with those warmer conditions lean us towards drier or more higher drought intensity. We can break these things apart looking at the temperature percentile map at in the bottom right here. That then shows us why the SPEI index was really leaning below average at all time scales, or this water year time scale. And so the whole Southwest, Arizona in particular, almost the entire state was in the top 10 percentile of water year temperatures. And then there's the precipitation in the upper plot here, showing that about half the state from the Mogollon Rim south, the central part of the state saw near normal, with the Southwest seeing above normal, and every other part of the state really seeing below average to much below average conditions. So that's looking at the water year. But then when we draw out and we just focus on the monsoon season, we do see record conditions show up in the long-term ranking. So this is from the West-wide Drought Tracker, these last couple of maps using PRISM data. If we look at a couple other data sets, we see very similar rankings in these metrics across the Southwest. So the upper plot there is the precipitation. So Arizona proper, very little area of Arizona saw anything but record dry conditions, little pockets of much below, just on the heels of record dry across any location in the state. And then coincident with a lot of those record dry conditions in the lower plot there is the record warmest conditions. Only the northwest or the northeast part of the states, just the northern parts of the states, weren't quite the record warmest, but were again on the heels, maybe second or third warmest in the historical record. Okay, so if we look at the monsoon precipitation, these are some plots I pulled together with daily PRISM precipitation records. And if we just focus in, Dave's going to go into more with New Mexico, but if we look at Arizona here on these maps, we can look at the locations that saw the precipitation. The upper map is the total precipitation. Following the Mogollon Rim, the upper elevations did see precipitation in the southeast part of the state, which is what we'd expect climatologically. But if we look at the lower plot, that's actually percentage of average precipitation. You can see there's really dark, these browns are very little precipitation, so much off of the percents of normal. And only these upper elevation locations, again, no place, very small pockets in Arizona maybe approached near average, and those would be localized locations that got heavy precipitation on a couple of days, but largely every part of the state saw below average precipitation. We can see sort of northwest Arizona and northeast Arizona. You can see Hopi and Navajo boundaries right here, saw very little precipitation and were anywhere from 50 to 25% of average, and even some lower numbers in those locations. And then right along the Colorado River Valley and the far western part of the state, there were many areas that saw no precipitation between June 15th and September 30th. If we carve the metrics up a little bit differently, this top map is going to be the percent of days that saw precipitation. So the higher elevations along the Mogollon Rim and far southeast saw maybe 35 to 40% of days saw observed precipitation. Much the rest of Arizona saw precipitation on 15, 10, or 5% of the days. So very infrequent precipitation events that did occur. And then this intensity index is going to be the total precipitation for the season divided by those number of rain days. And you can see here then that the lower deserts ended up picking up most of their total precipitation in 1 or 2 events. And so if we did see precipitation totals that were nearing average, say in some of these locations, which again, they didn't hit average, but if they were sort of edging up towards it, they may have occurred in 1 or 2 events. So they were high intensity events. And so that then, from a soil water balance perspective, that isn't particularly effective precipitation over the whole monsoon season. Just another way to slice and dice this is looking at the percent of Arizona that saw below, near, above, or much above average precipitation. So this brown category is the percentage of area of Arizona that saw below average. So less than 70%, 75% of their total precipitation for the season. So you can see here, it's about 90% of Arizona saw less than 75% of average. And then there's another probably, it's mostly 10% that makes up the rest of it that saw even near average. And near average in this instance is 75 to 125%, and just a sliver of any area that may have saw above average precipitation. And then if we look at the percent coverage over time here, this is just on any given day in the monsoon season, what was the percent of area of Arizona that saw measurable precipitation? And this just shows the kind of climatological progression of the season. And so in July and August, there was a burst where a couple of days saw almost 3/4 of the state seeing it. Another big break in August, which is where we should see the activity ramp up. We did see another pulse of activity towards the end of August, and then it was pretty much a shutdown for the rest of the season. And then so to look at the overall long-term historical rankings, I looked at the PRISM data, and this includes Western New Mexico and all of Arizona. If we look at this PRISM data going back to 1900, 2020 was quite by far the driest on record in this 120-year record. So the area average for this July, August, September period for this bounding box in this upper right plot here was 1.81 inches on average for the whole July, August, September season. That beats up 1956. And then even last year, which was a very dry year, came in 6, with this year being the driest on record. Okay, and then it was a not only Arizona, but a Southwest wide, including the sort of Central Rockies, which would see sort of northern fringe of this, and then all the way reaching down into Mexico. You can see the anomalies in the upper right plot here, and below average conditions all the way down to central Mexico, and really showing up in that percent of average plot there as well. Okay, so just to kind of walk us through with a particular location here, I took a plot from Winslow, Arizona, which is in northeast Arizona, so kind of up near the Four Corners where we saw these lingering droughts. And just wanted to break down last summer, last winter, and then this last summer to show you where we're getting this mixed signal and the sort of collision of lingering summer drought impacts, maybe some minimal recovery because of the wet conditions, but then summer impacts again. So if you're relying on summer precipitation, say for rangeland vegetation or wildlife resources or water resources, these back-to-back summers are really problematic. And getting that winter precipitation in between is helpful for some things, but may not alleviate some of those other impacts. So if we look at this plot from Winslow, we can see last summer, very, very dry monsoon, which was the driest on record for the station prior to this year. So this is 2019 monsoon season. Very little precipitation in the core of the monsoon season, sort of end of July, beginning of August. And then the one event that we did see across the Southwest in late September, which was not monsoonal, was actually early kind of winter storm event with some severe weather, did bring a little bit of precipitation, but only rounding out last monsoon season with 1.43 inches and 13 rain events at Winslow. And then we move into the cool season, which would be October 1st, and I run this plot through the end of May. The precipitation did pick up. We actually had a cold snap last fall, if anybody remembers, right around Halloween. Not all that dissimilar to what we're seeing here. That one was much drier, but had very cold conditions drop down out of the north there. And then set in motion, wasn't necessarily related, but set in motion, very wet November, picked up quite a bit of precip. And then really frequent precipitation all the way through the end of March and even an event in April. So as far as winters go for the Southwest, not really that bad. It's certainly helpful, but if you look at the end of the plot on the bottom there, the record high temperatures really picked up across much of the Southwest in late April and through May, and then just ran through the rest of the summer. And then here's the plot here for Winslow again for this last summer. And you can see we thought last summer was bad. This summer was even worse at this station. Now, not even quite half an inch of precipitation in 11 events, and then record heat all through the summer. So again, a bad summer last year, and then an even worse summer this year. And so what this does pick up in the longer term drought signal is these are plots I put together. This one's for Arizona. Standardized precipitation index at all time scales. So up the y-axis is longer time scales. So you're integrating over longer periods of time backwards. And at the bottom on the y is very short. It's the monthly time scale. And then we go along the x-axis, and you can see that's through time. And this far right here is showing us through the end of August. We're seeing at the very short SPI timescales, very intense drought conditions because of a run of very dry months. But we have still those winter conditions of the last couple of years, those wet months kind of running into the longer term SPI. So there was a little bit of recovery just on the precip side with integrating these longer time scales, but these punctuated short-term droughts create their own kinds of impacts. And then if we add temperature into it, this is that same index, standardized precipitation minus evapotranspiration index. You really see a lot more of those oranges come out because that's the overriding impact of higher evapotranspiration. So even a little bit of recovery of wetter conditions at short times are getting eaten away at with the longer trend in temperature and these punctuated, really warm and dry, shorter term seasons that we're seeing on top of it. Okay, and then finally, I'm kind of interested to see where we're getting these back-to-back seasons of drought conditions. And so I wanted to look back at the historical record for Arizona, and I pulled up all of the June through March periods. So this would be all the June through March periods for Arizona on average, so taking the whole state. And this goes all the way back to 1895 from the West-wide Drought Tracker. And so looking at previous June through March periods, so this gives us a sense that we just had a dry summer, but what if we're thinking forward now that this La Nina is going to bring dry conditions through March? So what were the past June through March periods? And so 2002 was the driest June through March period on record in this whole 120 some year record. And so that, for those of us in Arizona, means something because that was a very bad fire year in the spring and had huge impacts to wildlife and natural resources across the state and water resources. Well, the interesting thing with that was that the summer of 2002 was actually a bit wetter than what we saw here. So we were much drier. So June through September of 2002 was 4.22 inches for Arizona. We just saw 1.58. So if we have a very dry winter coming up here, we could be in that aggregate period much drier than we saw in 2002. This is not, again, it's not a forecast saying that we will be as dry as 2002, but I'm just saying that the back-to-back having a dry summer with the prospect of dry winter is an unusual situation for Arizona in the historical record, and our bad droughts really do have these back-to-back conditions on top of it. Okay, so I will yield the floor and give it over to Dave now. So thanks so much.
Great, let me get my PowerPoint ready. This is Dave. All right. Oop. There we go. Okay. Well, thanks, Mike. Just a quick sound check before I get started.
Yep, all looks good, Dave. Thanks.
All right. Thank you. And Mike did a great job and paved the way explaining the Southwest. And I just want to give some information on the monsoon and kind of what led up to the drought that we're seeing. If you pull up the U.S. drought monitor, it looks pretty nasty. So let's peel away some of the information. So as Mike showed some of the West-wide drought tracker maps, here's this summertime. On the left side is the mean temperature, and on the right side is the precipitation rankings from July, August, and September. So 3 months. And basically look at the colorings, so that that mustard color is much above normal, the top percent, and then the brown ones over is the record warmest on the left side. And then on the right side, you can see that brown is the record driest. So we've had a pretty much, as many people were calling it, a non-soon or a minimal zoon, however you want to peel it. And I mean, this is, we were seeing this year, and we've also had last year a very poor performing monsoon. So two summers in a row, we've seen starting to see drought impacts over several years in terms of the growing season. So this is something that's not a good trend that we're seeing. I just wanted to pull, Mike showed some great graphs of the standardized precipitation index, kind of puts things in perspective over many years. This is a time series of just for August. So it's a 1 month SPI for the whole state of New Mexico. As you can see, a lot of variability, but just look at over on the far right side of this. If I can turn my little highlighter on. Over here, the SPI for August is the second driest one compared. There's one other year where we had SPIs as bad as this past August. So I mean, this last August and statewide was the warmest on record. If you look at July, August was second warmest. June, July, August second warmest. And if you look at if you even put September in, which wasn't a particularly dry or wet, May through August was the warmest on record, as well as the driest, and about 51% of average in terms of the statewide precipitation. So 4.27 inches below the average. So not a good signal here. So I'm going to take a look at, I'm going to just look at 5 different stations across New Mexico, just to give you a sense of the variability of the timings and comparing to the normal. So if you start up in the northeast part of the state in Clayton from June 1st through the 1st of October, as you can see, we're had fairly wet end of July, dried off a bit in August, but toward the end of the summer, it pretty much ended up right around the long-term average, just a tad above it, so 0.06 above the average, so 8.37 inches over that period. Last year it was much drier. It's 5.61 over that same period from last year. So let's go a little further west and along the Rio Grande in northern New Mexico and at the Alcalde Science Center. Not a good picture there. Current monsoon, if you can look at them, June 15th through October 1st, 2.35 inches, that's 3.32 inches below average. So you can see some of these really long periods were very dry through most all of August and into beginning September, a few rain events, and then this rest of September has been really dry. So we come off another year of dry. Last year, only 4.3 inches. So let's go a little further south, just south of Albuquerque at Los Lunas. Current calendar year from June 15th through October 1st, that was 2.53 inches, and that's 2.28 inches below average. You can see same kind of pattern here. Very dry in August and just a few rain events at the beginning of September, but then continue drying. And another important part is that the summer really started off very dry. And another dry year last year, another really dry year, even drier at 2.12 inches. Going all the way up north near the Colorado border at Dulce, the current from June 15th through October 1st, 4.43 inches. That's just a little more than 2.5 inches below average. They're very thankful of this rain event at the end of July. It filled up some of the water tanks out there. I was just out there a few days ago just to inspect and maintain one of our weather stations out there. But it's been very dry most all of August, and just one rain event here, just less than an inch in September that provided a little bit of rain, but overall it's been very dry. Although all these maps don't include the precipitation from last night. So a few areas, I was looking at our Tres Piedras in this site that's near here, and they got right around midnight, they were getting around a little less than an inch of liquid liquid precipitation. So this is before last night. And the last one we'll look at is Farmington. As Mike mentioned earlier, the Four Corners has been struggling over several years. And this is another year of very dry. The June 15th through October 1st, 1.65 inches. So an inch, more than an inch below average. And look at last year, 1.13 inches last year. So it's several years in a row. Kind of the signature, very, very dry, nothing. And then you get a bump of a little more than an inch over a few days, and then really dry again. It's kind of these horizontal lines we don't like to see. This really drying out over all of August. And remember, August was one of the warmest on record. So the evapotranspiration levels were very high. If we were looking at some of the other products, I won't show them, but that's one of the triggers that we've been seeing when we're looking at the drought maps, is using the evapotranspiration products like the SPEI and EDDI, the evaporative demand drought index. Really high values in terms of stress to plants as well as evaporation. So I just want to go a little bit into the water, surface water, looking at, we had below average snowpack last year, melted out early. And then just want to give you a few gauge locations, 4 of them. So upper left, Animas River at Farmington. The little orange line, that's the long-term 94-year averages. And the blue line is the actual gauge values. And so we start off pretty low and continue other than just a few rain precipitation events to bump it up. And then that's on the Animas River. If we go further toward the east, on the Pecos River, this is right above Santa Rosa Reservoir. Same thing, the little triangles here are the long-term 44-year medians, and then the blues are the actual gauge stream flow. You can see these rain events, but you can see well below average and continuing on throughout the whole season. Upper right, both of the right graphs are on the Rio Grande further north. Embudo Station that has an 89-year record there. Here's the long-term medians, and here's what we got this year, so very low. And then going down to just in Albuquerque along the Rio Grande, same story. We've got even with some releases in the reservoirs, we still we're below, we're far below the long-term 46-year medians on the Rio. Another one I just want to point out, one of our largest reservoirs for irrigation, Elephant Butte Reservoir. This we just took this photo just a couple weeks ago, and we bottomed out at 82,000 acre feet. That's the 18th lowest out of 106 years. It wasn't the lowest on record. Lowest on record was back in 1954. However, in recent years, we've had a very low at the end of the irrigation back in 2018, we were down to 57,000 acre feet. And then, we mentioned that the La Niñas back in 2013, we bottomed out at 60,000 acre feet. So and this is just a photo of that at right around 82,000. I was there right at the lowest point. And I took a clip off of a press release for the Elephant Butte Irrigation District. They were talking about the low levels and the low numbers in terms of the storage on the whole basin. They said, unless conditions improve in the late fall and winter, we can expect 21 to be a critically low water supply year for the Rio Grande project, perhaps the worst in project history. So it just basically, unless they improve what it looks like now, it could be very low. And that's some impacts of the drought onto agriculture in New Mexico for the irrigated agriculturists. And I just wanted to show, this is a graph that we showed on our monthly drought work group. This is storages on New Mexico reservoirs. Just in the yellow box is the current as of October 20th. The storage on the reservoirs, you can see they're all below average, and some of them very far below average. Santa Rosa at 4,000 acre feet, and the last year it was 26,000. You can see Elephant Butte 85 compared to 428 last year. And so that just kind of gives you a feeling of the drought impacts, and a lot of it has been due to the well above average temperatures, increasing not only evaporation, but sublimation and later water coming down the river, not much water flowing. Some gauges have been noticing that's been a record low flows in some of the basins. I just wanted to kind of get a picture of the soil moisture, kind of looking at the water balance throughout the area. This is a NASA sport looking at the 1 month change in column relative soil moisture. You can see some of the areas like we've got a few areas in D4 in this area and over on the west side of the state bordering Arizona, and a few other areas are pretty dry, but it really does not show the picture of, we have to go a little further out, 6 months change. As you can see, this really dry pattern of soil moisture across most of all in New Mexico. And a few areas had some little bit of recovery in the Northeast and in a few areas over in Sandoval County, and not too bad. But other areas, the Four Corners still struggling, as well as the Southeast, and of course the far west in terms of soil moisture and lack of precipitation and warm. So all those have been contributing. I just want to show a couple little things I found. We had our drought meeting, and we were talking about impacts. I'm looking at the state forestry. They do a report. They're noting that they're seeing a lot of drought stress forests in terms of the pines, and they've also some of the infestations like needle miner have been making an impact. So just a picture I took on the left is showing some of the at 9,000 feet, some of the ponderosas. You can see some of the discoloration, as well as over on the right, the state forestry was showing some of the same areas. So there's some definitely drought impacts to upper elevation forests. And we're also seeing at the lower elevation. So this is just pick one of the NDVI from Modus products, seeing the anomalies. So we're seeing as this consistent signature of the lack of forage for the rangelands. And we're getting a lot of feedback from the ranchers and farmers and a lot of the lowland areas on the east side of the state, struggling a lot with reporting very poor conditions and having to sell off cattle. Just a few stats from the USDA statistics over on the right here. 76% of cattle receiving supplemental feed, and 43% right. And this is right now. This was like a couple days ago. 43% very poor to poor pasture and range conditions. So we're seeing this, and we haven't seen any recovery in any of these areas. There have been a few precip events, but they're very localized, very small. And then some of the areas we've seen some virga instead of precipitation in some of these areas. A few little areas like this little pocket here where we had about 4 inches, but that's about it. And then a few areas up along the Rio Grande, but other than that, it's pretty poor. Another product that's been useful is this product called GrassCast. It gave us a good heads up in terms of the what to expect in terms of grassland productivity. I think so far I've asked some folks and it sort of panned out. I'm just looking at the end of the season percents of the average of grassland productivity, and it's sort of most of the state, other than this one little pocket area up here in Union County, where they've seen some improvement, but other than that, it's pretty low across the state. And I just want to show the latest drought map, just to show the areas where we've been talking about. We've got D4 popped in, 7%, a little more than 7% of the state, and 67% in that D3 to D4 category. And we've got some precip that came by past day or so, but we're so far in the behind. We really need a lot more than just a 1 or 2 storms to make any massive improvements. And basically, a lot of the impacts have already occurred in terms of the growing season. They've had a freeze in most of the areas all over. I mean, it was 26 degrees in Las Cruces this morning. So the growing season's over, and so they're looking forward for what next year is looking like. And there's just a change. This is the last slide I'll have, just to kind of change over the last 6 months from last week to May 5th. And you can see the those areas, 5-class degradation over southeast New Mexico and even the far west over Grant and Catron County. So as some of those battlegrounds we've been seeing with the drought, and so there could be some other areas that pop up. That's kind of what we're doing. We're tracking drought. So I'll end it there and hand it back to you guys.
Thanks, Dave. We'll hand it over to Mike Halpert. You ready to go, Mike?
Yes, I am in the process.
Maybe we can see your screen.
Yep, there we go. Full screen now.
Yep, you're good.
Okay. All right. Thanks. I thought Dave and Mike did a great job of painting a pretty bleak picture as of the current conditions. I will, I guess, wrap things up here with talking about what you expect over the next roughly 3 to maybe 4 or 5 months. We'll talk about some of the climate factors, and the reality is for this winter, the big player is likely to be La Nina, which of course, as I'm sure a lot of you folks know, is not necessarily, or is not really a good thing going forward, but it is what it is. I'll start by talking about the current status, and I was seeing a few questions, and a few folks just wanted to maybe get a little understanding of the El Nino and La Nina cycle. So let me just, before I even talk about the current state, just remind folks that La Nina and El Nino refer to the state of the Equatorial Pacific. El Nino is the phase when ocean temperatures are warmer than average. La Nina is when they're colder than average. They then impact the tropical rainfall and the circulation over the tropics and subtropics, which eventually impact the jet stream over the North Pacific, which is largely why we care here in the United States, that the jet stream over the Pacific pretty much determines, or oftentimes will determine, the character of the upcoming winter. So as the current summary slide says, so we do have La Nina right now. It developed during the summer. We've seen a steady decrease in ocean temperatures, really from west of the international date line all the way over to the South American coast. The circulation is also quite consistent with La Nina. Things seem to be pretty well established, enough to the fact that we're very confident that this event will persist through the winter and likely into the spring. We've kind of asked already, longer term than that, and that's really hard to say. These type of events are notably tricky to forecast through what we refer to as the spring barrier. But at least at this point, we're very confident that this event has a lot of legs to it. This is a map of ocean temperature departures, or sea surface temperature anomalies, as it says on the slide, across the tropical Pacific. This is showing the 4 weeks ending October 17th, so about a week old. But one thing you can rely on with ocean temperatures is they don't change all that rapidly. And you can see the very, very characteristic La Nina pattern with below average temperatures, the blue shades, again, extending from the South American coast over on the right side of the plot to west of the international date line. That red box that I have highlighted on the plot, that's the area that we refer to as Nino 3.4. That's kind of the key area that we monitor, because that's the area that, when it either becomes warmer or colder than average, can really impact the patterns of tropical rainfall, and hence then the jet streams over either the north or southern hemisphere, depending on the season. So well established below average. If we look at time series for various areas across the Pacific and the area, again, I mentioned that Nino 3.4 is the second figure down on the right. And you can see that it was persistently positive the first half of the slide. So last winter into the spring, kind of flirted with El Nino, never really got warm enough to kind of affect patterns of tropical rainfall. And so we didn't really see an El Nino winter per se. But as we went through the summer, you can see ocean temperatures, you can see that blue line, a steady decrease, and it's actually become fairly impressive. Folks like to characterize the strength of these events by how cold the ocean is. Notionally, the weaker events are somewhere between minus 0.5 and -1, and the moderate events are -1 to -1.5. The stronger events would be departures greater than -1.5. You can see the last weekly value, and this is 2 weeks ago, but last week was the same, was -1.4. So, you know, looking like at least a moderate event and potentially even stronger than that. These little pictures show not just the surface, but they also show the subsurface. So down to 300 meters. Again, you're looking at the Pacific Ocean. 80 degrees west is roughly the coast of South America on the right side of the plot, and 130 east is over by Indonesia. The important part of this slide is that the blue areas, or the areas where ocean temperatures are colder than average, is really locked in. You know, it's not showing much evolution. If you look back at the top plot over on the right, it's in late August. And then you look at the current version in mid-October, and there's just not a whole lot of evolution. And that's typically what we see as events are becoming well established. Before this event ends, what will typically happen is you can see over in the western part of the left side of each of these little pictures, there's some yellow, so it's warmer than average. And typically that indicates that the thermocline is shallower than average, and we'll see that progress and kind of trap the cold water at the surface, and that kind of signals the end of this event. But at this point, there's really no sign of that happening. So again, the confidence that this is going to continue for a number of months is very high. These are various model forecasts that kind of go along with the time series we saw back a few slides ago. Again, the takeaway message here is that pretty much all of the models that we look at, and this includes international models as well as models run in North America, all stay below that lowest horizontal red line, which is the minimal cutoff for La Nina through the winter. So again, I'm very confident, you know, longer term, you can see there's a return back towards normal in generally all of the models. That's not surprising. I don't think I've ever seen model runs that forecast a multi-year event. Doesn't mean we won't see one. It just means that that's beyond the ability of the models really to forecast it. And this is our in-house model that I show. It's what we call the climate forecast system run by the National Weather Service. Interesting thing here, this is an ensemble run. So here we're looking at many runs initialized or begun at the same time with slightly different conditions. Interesting thing again is how unanimous all of the runs are, and really how tightly packed as you start looking at the time series plot on the left. As you get to DJF, every member, and I want to say it's somewhere 20 or 30 members, are all between -1.5 and -2, which would A, argue for a stronger event, but B, there's just very little spread there. So at least for this particular model, it's very confident that you know, we're going to see a continuation of cooling temperatures and a strengthening event. The official CPC forecast that was issued a couple of weeks ago, this is a once a month product, again, is where we get that 85% chance for DJF. You can see that the human forecaster sees this event ending as we go into MAM, which stands for March, April, May, and then kind of the expectations are a period of neutral conditions across the Pacific, and then, you know, who knows after that, and I'm not sure how much I would rely on those really long-term outlooks anyhow. So what do we care about what's going on across the Pacific? Bottom line is that, again, it strongly can influence winter. So here we're looking at composites of La Nina events. You can see down at the very bottom of the slide, there were 22 cases back to 1950. The temperature pattern basically favors warmth across the south and up the East Coast, and colder temperatures across the north, again, related to the positioning in the jet stream. Maybe a little more relevant for this audience is precipitation. Again, favoring a dry south and a wetter north. The figure on the that's the average departure. That's the figure on the left. The figure on the right is the frequency. So it's the percent of the 22 cases that we've seen the indicated sign. And if you look over Arizona, New Mexico, you can see shades of yellow and some reds. So, you know, unfortunately, it's a pretty strong, reliable signal. I guess if, you know, you want to have any optimism, it's not 100% certainly. I mean, there have been cases in the past that, you know, did not follow the typical pattern, but you know, again, when we're issuing our probabilistic forecast, as you'll see, and when I get towards the end, we are favoring you know, what's happened more often than not. Here are another just a quick look at some of the models. This is what's called the North American Multi-Model Ensemble. It's about 8 models run in various parts of North America, including Canada. The temperature pattern is basically a warm pattern coast to coast with, you know, pretty good confidence. In particular, if you look at the probabilistic version, you know, the probabilities down in southern New Mexico exceed 80%. Even scaled that by how skillful the models have proven to be in the past. That area in southern Arizona, this is the figure on the right, still exceed 50 to 60%. So I'm pretty confident on temperature. Precip again, same kind of picture. It's not surprising. It looks a lot like the La Nina composites, given that all of these models have La Nina, and they certainly understand how La Nina impacts circulation during the winter. Again, pretty high confidence, pretty high probabilities for a dry December, January, and February. So having shown those, I'll now just get to the forecast. They are probabilistic, and that's important to remember that what a probabilistic forecast tells you is that you're not always going to get what you expect. You know, if you're told there's a 70% chance of rain, well, that means that 30% of the time it probably won't rain, assuming your probabilities are reliable. You know, of course, if you were going to take a bet, well, you'd want to bet on the most likely outcome, but you shouldn't necessarily be surprised if you don't always hit what you're expecting, don't always get what you're expecting. Anyhow, the best chance for a warm winter again is in the Southwest, in particular Texas and New Mexico, exceeding 60%. You know, most of the rest of New Mexico and Arizona is better than a 50% chance of above average temperatures. And precipitation, you know, again, we also, you know, based on what I've shown so far, it shouldn't be a surprise that we're strongly leaning towards a dry and warm winter across both Arizona and New Mexico. And the impact on drought, not surprising. This is the seasonal drought outlook. It actually only runs through January. The other forecasts were for December, January, and February. But you can see the entire states are in drought, and you know, we don't really see you know, much hope for improvement. It's not to say that it can't, but certainly it's not likely to happen. Again, not the message I wanted to bring to you folks. I actually did one of these yesterday for the Pacific Northwest, and there we were much more positive as a shift in the jet stream favors the storm track really to be further north this winter, you know, in a general sense. So just summarizing, we have La Nina. We expect that to continue, and then we just talked a little bit about the northward shift, favoring below normal precipitation as well as above normal temperature and likely persisting drought throughout the winter months. And I will stop there and turn it back to a moderator.
Thanks so much, Mike. So now we don't have a whole lot of time for Q&A, but we'll get as many questions in as we can. And if you're able to stay with us a little bit past the hour, that would be great. And if we are not able to get to your question, we'll follow up with you after the webinar. But please type your question into the Q&A if you do have a question. We have had a few come in. So the first question, I think this one goes to Mike Crimmins, but any of the panelists feel free to chime in. So this question is from Karen Peterson. Are we still in a long-term multi-year drought, or did we get out of that and now we're in drought again? And then along with the slide that was showed, did the Chusca Mountains experience low precipitation this past summer? And then one more question, how extreme is the drought in the Navajo Nation area?
Yeah, so this is Mike Crimmins. Yes, I don't believe we have exited the long-term drought. I think we've had a couple of here and there decent summers and decent winters, but they really haven't added up to a run of seasons where the precipitation was sort of trending above average. So I do think that that does leave us in those longer term drought conditions. I don't know about the Chuscas this summer. I don't know of any sort of the local reports. The gridded data did suggest that it was dry and did not see near average precipitation, and definitely on the below average side. And so the drought monitor map is still showing those long-term drought conditions, because they never actually recovered, and even some of the longer-term maps, as that sort of severe to extreme across the Northeast Arizona.
Yeah, this is Dave. I just did a query for the Whiskey Creek station on top of the Chuscas, and from June through right now, they've had 4.2 inches. So that's the same amount as 2019, and they've had 2, 4, 6, 8, 10, 12. That's out of 12 years. So it's not a real long record, but that's their lowest they've had. So it's tied to 2019. So it's been pretty dry. I can see very little going on through July, all of June, very dry. And they've had a few rain events end of July and then the end of August, but it's still pretty dry there.
Thanks, Dave.
Yeah, thanks, Dave, and thanks, Mike, as well. And so this next question, Dave had typed an answer in, but I wanted to open it up to everybody. This is from Dale Goodman. So thoughts on why the monsoon is essentially not happening. I had understood that the models were showing hotter, drier, later monsoons, but not non-soons like we saw this past summer. So thoughts on that?
Sarah, did you want, in addition to what Dave had posted?
Yeah, I guess so. If you had additional thoughts, if not, we can move to a different question. But
yeah, I think my take in kind of poring over the data and talking to some sort of other regional experts on this, there doesn't seem to be a single cause of the monsoon failing. It was several periods where the monsoon just couldn't quite get its act together. So I think it was a convergence of a lot of moving parts that didn't quite mesh together. And I don't think this is necessarily a signal of a longer term trend towards failed monsoons, right? So if this happens next summer and then the following summer, we should talk. but at this point, I think we can chalk it up to some bad luck. The temperatures, though, that occurred concurrently, so it doesn't rain, it does get hotter, but it is now hotter with the longer term climate change trend on top of it.
Perfect, thanks. I think this next question goes to Mike Halpert. Does global warming mean more La Nina events in general?
I haven't seen anything that says that. El Nino and La Ninas have been part of the kind of the cycle of the Pacific Ocean. There's actually various proxy records that go back thousands of years on that, if not longer. There was for a period, I know there were folks who were concerned that global warming might actually result in more El Ninos because it's a warming, and that's what El Nino is when the ocean becomes warmer than average. But as long as everything kind of warms uniformly together, and we're not necessarily seeing that, it's really becomes the gradient or the change in temperatures across the Pacific that would matter. So I'm not aware of anything that argues that global warming really leads to any definitive change in El Nino or La Nina, and certainly not in resulting in more La Ninas.
Great, thank you. So we've got a set of questions that are related to the current weather that we are experiencing. So the first question from Jim Thorpe: where did this recent snowstorm, if you're somewhere where it snowed, come from? It looks like they got 9 inches in eastern New Mexico, our first precip since early September. So where did
I'm not sure who's the weather expert on here. I'm the climate guy. Yeah. I think it's hard to ascribe any one storm to anything. I mean, we kind of go through this. We've gone through it more historically when we're dealing with El Nino, and there's a storm. It kind of rains in California, and everybody gets all excited and goes crazy, and it's like, oh, is that an El Nino storm? The patterns that we typically see with La Nina would argue for a shift, but there's a lot of variability throughout the course of the season, and given that we're only here in October, it's certainly unusual. But there was, I guess it probably didn't get down into your area, but I know parts of Colorado had a big snowstorm back in September. So I mean, weather is quite random, and I don't think it says anything certainly about necessarily the character of the winter, or even really the character of the next couple of weeks. Before I got on, I was looking at some of the outlooks for like next week, and it looks like a return to a warm and dry pattern over the Southwest, and somebody was commenting that could happen as soon as tomorrow. So
yeah, and Mike, just to jump on that a little bit too, we had an event, as I mentioned early on in the webinar, we had a cold spell like this last fall too, and I believe that one you could actually connect back to upstream typhoon in its extratropical transition. So all the way on the other side of the Pacific, these large typhoons can get caught up in the jet stream and put big waves that will translate downstream. And I don't know about this particular one, but they do show up in the Southwest kind of this time of year, and they don't necessarily portend for the rest of the season.
Yeah, and Paul put into the chat that this is a short wave that came from British Columbia, just an early season winter storm, really.
Yeah.
But we did have an email question that's related to this. So what impact does this current blizzard have, or is it having on the drought and river water flows? He gave the stats that Spanish Peak had over 2 feet of snow, Ski Taos well over 1 foot. So do we see this having any sort of impact on the drought, and what does this mean for river water flows, for surface flows?
This is Dave. I mean, every precip event helps. There's usually not one event that will cause major improvements. I mean, we have to kind of put in perspective. I mean, this is, we're at the end of the growing season, and things are kind of in hibernation now because a lot of our freeze dates have already occurred. We are seeing, I just pulled up some of the USGS gauges on the Rio Grande. So there's been a little bit of uptick. We're up to like 190 at Albuquerque. It was starting off at like 133. So just a little bit of flow, as well as going down into Elephant Butte. Just maybe 10 more CFS. Not right now, because the input into the Elephant Butte is right around about 100, and it's peaking up around 110. So I mean, there's little events that will definitely help, but the only year that we ever got something major on specific events was like 1941, where we had a bunch of events, and they basically made a big change in surface water. But that's something we're not expecting this year at all. I think it always helps in soil moisture to store that. But I think looks like it's just going to rebound again next week. At least down here, we'll probably be up to the upper 60s again. And, we may lose some of that through evaporation, but it always helps.
Great. So this next question, I'm not sure if anybody on the panel can answer this, but I'm going to throw it out there. Are there any data on how these Southwest droughts impact insect communities and or how that magnifies to other taxa that prey on insects, such as birds? Anybody
Yeah.
want to give it a shot?
I don't know. Sarah, this is Mike. Yeah, it's a
Yep.
great question, but I'm not sure.
That
Well,
could be a
Silas-
future webinar on impacts to the biology.
Yep. Well, maybe if anyone knows of an expert that might be able to answer that, they can type it into the chat so Silas can follow up. Let's see.
Sarah, this is Joel. We probably have time for just one more question if you want to just,
Right. I
if
haven't
this will be
even.
the last one.
Yep. Okay, so Mark McCabe says, I read an article from Southern California Weather Force saying that an extreme La Nina can have an opposite effect as is expected, resulting in above average precip. Is there any chance that that is accurate?
Well, you know, when you use the word can, well, sure. Like I said, these are probabilistic forecasts. And if you look at the historical record, you know, maybe one or two of the stronger La Ninas did result in, you know, kind of the unexpected result, and it ended up wetter to the south. It's not what we typically expect. You know, I was kind of just as I saw the question come in and I was looking. And so if you go back to like the 1998-99 event, which was a pretty strong event, and that was quite dry in the Southwest. 2000, I think it was 10-11 actually was on the wetter side. So there is some degree of variability, but you know, you kind of go back to that one figure I showed that had the 22 events. And, you know, I would say that you're looking at probably close to 70%. So probably 15 or 16 were drier than average. I mean, it does leave you a handful that were wetter than average. They could have been stronger ones. And we're not saying necessarily that this particular event will be strong. But, you know, at this point, you know, if I had a bet, I would bet on a dry winter, but certainly, you know, you don't win all your bets, right? So, you know, that's kind of the best guidance we can give you at this point.
Okay, thank you. That's about all the time we have. We'll follow up with everyone. If we did not get to answer your question, we'll follow up with you later. Joel, was there anything you wanted to mention?
Well, sure. Thank you, Sarah. I just wanted to take some time to thank Mike, Dave, Mike, you, Sarah, and also Katie Steele, who's been doing some work behind the scenes for us today, for sharing your time and your expert knowledge with us. This has been great, and I've learned a lot, and I hope that those attending have also learned a lot. That ends today's webinar. We hope all of you can stay healthy and stay safe.